Hi, have you ever heard brain-computer interface? It's a totally fascinating technology, and I'm going to talk about it today. Okay, right now we need a little bit of neuroscience knowledge. Let's say you want to move your hand, right? And to move your hand, there are actually three steps happening in your body. It's think, signal, and action. Well, our brain is like a commander. Its job is to send orders every moment. After we have an idea, tiny electric signals will travel lots of nerves to reach out our hand. And finally, the muscle in our hand receives the signals and they know that, okay, the brain wants them to move. So they just move. But what if these electrical signals don't go to your body, but they go straight into a computer? Okay, that's where the idea of output BCI comes from. Alright, let's move on to how they actually work. The whole process can be divided into three parts: recall, decode, and action. Well, let's start with the recall part. How does it actually capture brain signals? Well, firstly, remember that neural communication happens from one neuron synapse to another neuron synapse. And for brain computer, they replaced the receptor synapse with an electrode. Yeah, and these electrodes, they will record the neural signals. Well, but is it nice enough? No, that's still too weak. So, after brain signal was recorded by the electrodes, it still needs to be amplified and filtered. Then it's a nice and clear brain signal. And we can move on to the next part, which is decode. The first step is feature extraction. The brain signals are actually quite messy, and we only need specific segments that contain useful information. Then comes pattern recognition. Because computers, they cannot directly understand these neural signals, therefore we need to train the system to recognize and match the signals the user intends to specific common patterns. And in the end, actions. After the computer learns the signal, all we need to do is just to think. And after we think, the computer will understand by itself and it will do the action by itself. So that's how brain-computer interface works. It records, decodes, and turns out into actions. And it makes a lot of things possible. For example, a disabled patient nowadays can use BCI to move a robotic arm or type with other people just by their thoughts. And I think that's the heart of UCL Grand Challenge: improve humans' well-being, using science and engineering not to just understand the world, but make this world a little bit better.